Hello guys, welcome to the session with Mr. TSEBE, and we'll still be doing eigenvalues and eigenvectors part 3. Suppose that we are given a matrix like this and they want us to find eigenvalues and eigenvectors, but we know the formula for eigenvalues. For eigenvalues, we know that the determinant of this matrix A minus lambda multiplied by this identity matrix equals to 0. So, but determinant of A minus a lambda multiplied by this identity matrix is the same as 1 minus lambda 1, 2, 0. Remember, we are subtracting diagonally. Minus 1, 0, 0, 7 minus lambda, which is the same as 0, 0, 0. Or you can just write 0. So for us to find the determinant of this part, we are going to say 1 minus lambda, which is the same as. So if we consider this part and then we go this side and we go this side, we remain with this part, which is the same as 5 minus lambda minus 1, 0 minus 0, 7 minus lambda. This is the part we are having. So we are going to minus by 1. So if we consider this and we go this way and that way, the matrix that we are having will be 0, 0, minus 1, 7 minus lambda. That is the matrix that we are having. That is the matrix that we are having. So if we consider 2, so right now if we consider 2 and then we go this way and then that way, we will see that plus 2, that this is the matrix that we are having. We are going this way and that way. So it will be 0, 0, 5 minus lambda and 0. That is what we are having. So, but we know a matrix of 2 by 2. This will multiply this one and subtract the multiplication of this 2. Even here and even here. So this will be 1 minus lambda like that. Or this part equals to 0, 0. Because of right now we reduced it to 2 by 2 matrix, so it has to be 0, 0. So we're having 1 minus lambda. So this will be the part 5 minus lambda, 7 minus lambda, minus 1 times 0 is, it will just be 0, minus this part. 0 times this will be 0 minus 0, and then plus 2. 0 multiplied by this one is 0, and 0 multiplied by that one is just 0, and this equals to 0. So this is the part we are having. So this will be 1 minus lambda. This will be 1 minus lambda, 5 minus lambda, 7 minus lambda, all equals to 0. So if we divide by 1 minus lambda and then even this side by 1 minus lambda, you will see that we are going to be having 5 minus lambda, 7 minus lambda, which is just 0. So my lambda will be 5, or my lambda will be 7. So since we are having lambda which is equals to 5 and lambda which is equals to 7, we call them eigenvalues. Right now we can go and seek for eigenvectors. So let me write them here. My lambda was 5 and my lambda again was 7. So let's go and find eigenvectors. So for eigenvectors, we know that A minus lambda multiplied by I x equals to 0. We are saying equals to 0. But when lambda equals to 5, we want the eigenvectors when eigenvalue equals to 5. So we can substitute by 5 here. So it will be 5i, which is the same as 1 minus 5 according to our equation. 1, 2. We are subtracting, they're going to leave in here. 5 minus 5 minus 1, 0, 0. 7 minus 5. So this will be x, y, z, which is the same as 0, 0, 0, like that. Just like that. So simplifying this will give us minus 4, 0, 0, 1, 0, 0, 2 minus 1 minus, 2, x, y, z, which is the same as 0, 0, 0. So, but we are going to let x equals to 1. But by just looking at these things, we can see that using this equation, minus z equals to 0. So z equals to 0, and even here 2z equals to 0. So z equals to 0, even here, using this equation. So since I know the value of my z and my x, I can substitute in this equation, which is minus 4x plus y plus z, which is 0. But minus 4 is 1 plus y plus 0, which is 0. So my y will just be 4. So x, y, and z will be the same as 1, 4, and also 0. So we can multiply here by 1 over 4. If we multiply this by 1 over 4, we'll be having 1 over 4 here, and then 1 here, and then 0. So this is the same as this one. So right now we want eigenvalues when x equals to 0. When x equals to 7. So when x equals to 7, we are going to substitute here minus 7i. So this will be the same as x. This will be the same as 1 minus 7 is minus 6. 1, 2. 1 and 2. 0. And 5 minus 7, it's minus 2. Minus 1. This will be 0, 0. And the 7 minus 7 will just be 0. And then this will be x, y, z, which is the same as 0, 0, 0. Just like this. Just like this. So we will let x to be equals to 1 as usual. But from this statement, we can see that 2y minus z equals to 0, even from this one. So minus 2y equals to z. So minus 2y equals to z. So I can substitute here. I'm having minus 6x plus y plus 2z, which is equal to 0. So I can substitute where I see 6, I substitute by 1. Plus, what is my y? My y is, let me just leave it like this. Let me just leave it like this and divide by minus 1. And then I'll be having 2y minus z. So I can substitute wherever where I'm seeing z. This will be 2. Wherever where I'm seeing z, I can substitute by what? Minus 2y, which is equals to 0. So this will be minus 6 plus y minus 4y equals to 0. And then this will be minus 3y equals to 6. If I divide by minus 3, I can see that my y is actually minus 2. So the value of x, y, and z will be equals to 1 minus 2, and my z, I can just come here on my z, I can just come here and substitute. Let me substitute it here. So this will be minus 2, since my y is minus 2 even here, equals to z. So my z here will just be 4. So 1, 4, 1 minus 2 and 4 will be the basis. So guys, this is the end of the session, and if you enjoyed this, you can please subscribe and also send it to your mates and then enjoy. Thank you.